Hello. Now we are going to look at calculating some missing angles. So we know that there are 180 degrees in a straight line. This is one of the axioms or the assumptions that we make, that if we start facing to the right and we rotate it around so that we were then facing to the left, we'd have rotated through 180 degrees. So based on that, we can find missing angles because we know this fact that in total we'd have to go through 180 degrees. So if we look at this situation here, where we can think of facing off slightly upwards, and then we rotate down and we end up facing downwards to the left. We've rotated through x degrees, so an unknown amount of degrees that we rotated through, and then we rotated through 80 degrees. Well, we know that in total we'd have had to have gone through 180 degrees. So we know that at 80 degrees plus our own unknown number of degrees of rotation must add up to 180. And where we have a situation like this, where we have angles added together that add up to 180, that add up to the rotating around a straight line, we call those angles supplementary. So supplementary angles add up to 180 through rotating through a straight line. Now at this point, once we've done this active translation, we can see that we can just rearrange our formula to find out what x is. We just take 80 from both sides, and x ends up being equal to 100 degrees. And that's all we need there. So if we see a straight line we've rotated through, we know we've gone through 180 degrees. Now if we think about this for a moment, if we rotate through from right to left, we go through 180 degrees. Well, what happens if we kept rotating all the way around back to where we started? We did a full rotation. Well, then we'd have gone through two 180s. We'd have gone through 180 and then rotated around 180. And in total, if we add 180 degrees plus 180 degrees of rotation, we end up with 360 degrees. So if we rotate all the way around back to where we started, we have to go through 360 degrees. So that is a fact that we can use for a slightly different style of question if we get it. If we look here, we have 110 degrees, 100 degrees I should say, plus 110 degrees, plus 30 degrees, plus 120 degrees when we add all of these rotations up. So if we started here and rotated all the way around, we'd have ended up going through a total of 360 degrees. So that's two different ways of looking at this fact, that if we're rotating all the way around a point, we end up going through 360 degrees. And can we use that to solve our problems? Well, we can. If we know we go through x degrees, an unknown number of degrees, and 40 degrees, and then 4 times x degrees, so 4x degrees plus 120 degrees, well, I know in total I've gone through 360 degrees. So if I add up all my rotations, say I start here, I'm going to rotate through x degrees, and then I'm going to rotate through 40 degrees, and then I'm going to rotate through 4x degrees, and then I'm going to rotate through 120 degrees. I know I've gone all the way back around to where I started, so I've gone through a total of 360 degrees. And we don't particularly need to write down our degree symbol in this context. And now I see I have a simple equation to solve, a fairly simple equation to solve. I have some like terms I can add up. So I end up with 5x's plus 160 is equal to 360. And now I need to rearrange this formula now that I've simplified it. So I get rid of my numbers on my left-hand side because I only want to have x left on the left-hand side. And I end up with 5x is 200. So I divide both sides by 5, divide both sides by the coefficient of the x, because 5 divided by 5 is 1, and we want to know 1x is equal to 40 degrees. So our x here is equal to 40. Now, the last fact that we need to think about can actually be figured out from what we've already done, which is that vertically opposite angles are equal. Now, what does it mean to be vertically opposite? Well, it means that if we have an angle A here, if we have two lines crossing each other, so two straight lines crossing each other, we don't have that here. We have the angles all, the lines all kind of going crooked to each other. There's no straight line through here. But if we did have two straight lines cutting through each other, we would end up with this angle being the same as this angle. And we can work out why that would be based on the work we've already done for our straight lines. But the fact we need to know is this is what it means to be vertically opposite. If we have two dead straight lines cutting across each other, the angles on opposite sides of where they cross, so vertically opposite on opposite sides of where they cross, must be the same. And I say we can work that out from what we've already discussed here. So how can we use that to solve our problems? Well, if we get a situation like this where we have two dead straight lines crossing over each other, then we can use this fact to find all of our missing angles here. So even though we're only given one angle here and we're asked to find all three of these, we actually have enough information because we know this fact about vertically opposite angles. Before we use this, I want to point something out to you. If we look at the example that we just did, this almost looks like a straight line. Almost. But we have to be very careful that it's only when we have a perfectly straight line, like what we've got in this question here. So we just have a ruler going straight through, crossing our two dead straight lines, then we can use this vertically opposite fact. Here, where there's a little bit of a kick in the line where it just goes offline a little bit, then we can't use this fact at all. It doesn't work. So only when we have dead straight lines crossing each other are we able to use this fact about vertically opposite angles. Based on this, based on what we've argued here, we have 60 degrees here. Well, the angle that's vertically opposite, that's straight across from where they cross each other, must be equal to 60 degrees. So we now know that M must be equal to 60 degrees because they're vertically opposite. And if we use this fact, we should write it down. So I'm going to write that down there. The reason we need to write this down is that this is going to develop into much more complicated geometry, and we want to get into the habit of describing why it is we can do what we can do. So this is one of our first rules in geometry that is a little bit more abstract. It's a little bit harder to immediately see, and we're going to build on this to get to quite complicated rules that we can use for figuring out problems in geometry. And when we get to those more complicated situations, being able to tell the story of why we can do each step will be absolutely essential. We won't get marks in our exam if we don't do it, if we don't explain why we can do each step. So we're going to start out right from the beginning, describing why we can do each step that we're going to do. So we now know that M is 60 degrees because it's vertically opposite the 60 degrees. So we now have that one sorted. We've got M done. How are we going to figure out N and K? Well, there's two ways that we can look at this, and we're going to discuss both of them. Based on what we've already talked about with our straight lines, we know that if we go all the way around here, so if we take this complete angle on this side here, we know 60 plus N must add up to 180. So we know that 60 plus N, or N plus 60, must equal 180. And then just rearranging our formula to get N by itself, we know that N must be equal to 120. And you can make exactly the same argument with K. If we take this as our straight line, we'd have 60 plus K, or K plus 60, would have to add up to 180. The other way that we can look at this, or another way that we can look at this, is to think about all of the angles in the circle. So we can do exactly the same thing with K. I'm going to rewrite this a little bit neater. So now that's written out a little bit tidier. We've found N and we found K and we found M. But there's another way to do this, and it's important, particularly in geometry, to look at these situations in different ways so that we build up this toolkit, this ability to tell the story of geometry. And we want to start doing that from the beginning, from now. So we know that N, the angle N, is equal to the angle K. So this is another way of solving this problem. We've already figured out the answer, but we now know this vertically opposite rule, and we also know about our other work that we've done. So can we use that to figure out the value of N and K? Well, we know that they're equal to each other because they're vertically opposite. So I'm going to abbreviate that. They're vertically opposite. So that means that we now know m is 60. So if we know that n and k are the same thing, well, let's call them x, because that's what we often call an unknown. So we know that some angle plus 60 plus 60, what must that all add up to? It must add up to 360 degrees. So we know that, let's call that x. So n and k are going to be called x now. So we know that if we start here and start rotating around, 60 plus x plus 60 plus x must add up to 360. So 60, that's our angle m, plus x, our unknown angle k, plus 60 plus x must add up to 360 degrees, because we've gone all the way around. 60 plus x plus 60 plus x. So we add up our like terms, and we get 2x is equal to 2x plus 120 is equal to 360. We subtract 120 from both sides to get at the x's by themselves. So x's on the left and numbers on the right. We get 360. Divide by 2. And therefore x is equal, what did I just say? I apologize. That's not equal to 360. X is equal to 240. My apologies. So when we've rearranged and then divide by 2, we end up with x. So therefore x is equal to 120 degrees. And we know that that's what n and k are equal to. So that's a different way of telling ourselves the story of the question. And as we do geometry, as we build up this toolkit of methods for solving problems, it will be important to try and look at these problems in different ways so that we build up our skills in being able to tell the story of geometry. Because if we can do that, geometry is a nice topic, but if we avoid writing down our stories as we do it, it can become very overwhelming. So we want to set ourselves up to succeed in the long run. And that's what we need for now.